Hi guys, welcome to day 17th. Today's topic is going to be continued hybridization. Now, I did give you two types of hybridization the other day, and I did want to kind of review those real quick. And kind of the thing I want you to watch for is the number of effective pairs. And what that is really it's your neighbors plus your unshared pairs. So I'll go through a couple of examples, and if you can kind of figure out what the effective pairs are, you can kind of figure out what hybridization is. So I think the example that I gave you the other day was sp3 hybridized. And what this is, pick an element like carbon. Carbon has an outermost s orbital, and carbon has three outermost p orbitals, okay? Each of which can hold two electrons. And in the case of sp3 hybridization, these four orbitals combine, or they hybridize into four new orbitals, and four sp3 hybrids are formed. And each one of those sp3 hybrids can form a bond. So if you look at the case of methane, carbon has four neighbors, okay? So carbon has four neighbors. Carbon has zero unshared pairs, so carbon has four effective pairs, okay? Carbon has four single bonds. So each one of those bonds is a sigma bond. All four of those bonds are identical. And in the case of methane, none of those bonds are pi bonds, okay? So the other type of hybridization that we talked about the other day was sp2. And in the case of sp2, we can use carbon as our example again. Um, Carbon has four valence orbitals. It has an s orbital and it has three p orbitals. But in the case of sp2 hybridization, only three of those orbitals get involved in the hybrid. So what you end up with is three new orbitals, and those three new orbitals are called sp2 hybridized. Now, on a side note, I don't think I mentioned this the other day. You have this p orbital, and this p orbital is unhybridized, okay? So three of those orbitals do become hybridized, forming three new orbitals, three sp2 hybrids, and one of those valence orbitals is unhybridized, okay? And let's go ahead and just, I'm going to do formaldehyde. If you look at formaldehyde, focus on carbon. Carbon is at the center of this molecule. Carbon has three neighbors. Carbon has zero unshared pairs. So carbon has three effective pairs. And in the case of carbon, it is sp2 hybridized. Now let's kind of take a little closer look here. Okay. Okay. We have a sigma bond there. Okay. So this is a sigma bond, okay? This is also a sigma bond, and it doesn't really matter which one we pick, but one of those bonds between the carbon and oxygen is a sigma bond. But also, one of those bonds is going to be a pi bond. So carbon forms three sigma bonds, and it's those three sp2 hybrids that form the sigma bonds, but that unhybridized p orbital is going to form a pi bond with the oxygen neighbor. So I don't think I talked about unhybridized orbitals the other day. I thought that I'd bring that up now. So let's move on to the next few types of hybridization. Okay, the first of which is going to be sp hybridization. Okay, so what's happening? We can use carbon as our example. Remember, carbon is king. Okay, carbon has four outermost orbitals, and in the case of sp hybridization, two of those orbitals hybridize to make two new orbitals. So what you're left with is you're left with two sp hybrids. But don't forget, you also have some orbitals over here that are unhybridized. So we have two p orbitals that are unhybridized, okay? Okay, now let's look at a molecule that is sp hybridized, okay? Take a look at carbon here. Now, if we're talking about carbon, carbon has two neighbors. Carbon has zero unshared pairs, so carbon has two effective pairs, and carbon is sp hybridized. Now let's take a little bit of a closer look. Carbon forms a double bond with the oxygen on the left, and it forms a double bond with the oxygen on the right. So the first bond form will always be a sigma bond, okay? And this sigma bond is going to be formed by these sp hybrids. I'm going to change colors on you. Let's go to green. But carbon also forms a double bond, okay? And the double bond, or the second bond that is formed by your unhybridized p orbitals. So we've got these sigma bonds that are caused by the head-on overlapping of the sp orbitals, but carbon also forms a pi bond with its neighbors, and it's caused by the side-on overlapping of these p orbitals, okay? So there are two sigma bonds and two pi bonds in this molecule. Now let's change our focus a little bit. We talked about carbon. Let's talk about oxygen here for just a second. So focus on oxygen for the next minute. Okay, oxygen has oxygen has one neighbor, carbon. Oxygen has two unshared pairs. So oxygen has three effective pairs. Okay, and because of that, oxygen is sp2 hybridized. Okay, so in the case of oxygen, it has three sp2 hybrids, but it also has one p orbital that is unhybridized. So we can look at effective pairs even if the atom is not in the center of a molecule. So carbon was sp hybridized and oxygen was sp2 hybridized. Okay. All right, let's look at another example. Let's look at acetylene. And it really doesn't matter which carbon we pick because they're really both identical. So if you look at carbon, carbon has two neighbors. Carbon has zero unshared pairs, so it has two effective pairs. In the case of carbon, it is going to be sp hybridized, okay? So in the case of carbon, there are going to be two sp hybrids. I'm sorry, that's just sp, not sp2. Two sp hybrids, but it's also going to have two p's that are unhybridized, okay? Now let's look at the nature of these bonds here. Okay, this bond is going to be a sigma bond, and it doesn't really matter which one we pick. One of these bonds between the two carbons is going to be a sigma bond, but I'll change colors on you again. Okay, we also have two pi bonds, and these pi bonds are formed by the p orbitals that are doing side-by-side overlap, and the sigma bond is formed by the sp hybrids that are doing head-on overlapping. So sigma bonds caused by head-on overlapping. The sigma bonds form first. All right, let's look at another example. I think examples is one of the best ways to understand this. Okay, nitrogen. So take a look at nitrogen. Nitrogen has one neighbor. Nitrogen has one unshared pair. So nitrogen has two effective pairs. That tells me that it is sp hybridized. So in the case of nitrogen, nitrogen has two sp hybrid orbitals, and nitrogen has two p orbitals that are unhybridized. Keep in mind, the first bond form will always be a sigma, and it's going to be the sp hybrids that form the sigma bond, okay? But also, we have two unhybridized p's, and these are going to form your two pi bonds, okay? So the blue bonds are pi bonds, and the pink bond is a sigma bond, okay? All right, next example. All right, so guys, there are some types of hybridization actually some atoms can be exceptions to the octet rule. And my example or my explaining or my reasoning for this earlier in the year was that sometimes D sublevels get involved. So if you look at phosphorus pentachloride, phosphorus is your central atom, and phosphorus has five neighbors. Phosphorus has zero unshared pairs, so it has five effective pairs. Basically, phosphorus has 10 valence electrons. And what's happening really here is that some of these D sublevels are getting involved. So what's happening is that a D is hybridizing with a P, and the D is hybridizing with one of the S's and three of the P's, and what you're ending up with is five new orbitals, five sp-d sp3 hybrids, okay? So if your effective pairs is 5, it's going to be dsp3 hybridization. And take a look at sulfur hexafluoride. Sulfur is the central atom. Sulfur has 6 neighbors, Sulfur has 0 unshared pairs, so sulfur has 6 effective pairs, and you're going to end up with 6 D2 sp3 hybrids. Okay, so guys, I think the sheet on the next page is going to kind of explain some things to you. And the bond angles are kind of explained in there. I don't want to go into great detail, but just think of effective pairs. If the effective pairs is going to be 2, it's going to be sp. If the effective pairs is 3, it's sp2. If the effective pairs are 4, it's sp3. If it's 5 or 6, then we know that the D sub levels are getting involved. So guys, I know it's a little bit confusing. Watch some of the videos that I've linked on Google Classroom. If you have questions, you can email me or shoot me a private message on Google Classroom. I miss you guys. I love you guys. I'll talk